All right. Find the area under the graph. Just so you know, if you keep pushing the desks up and they make it to my desk, I'm going to make you guys clean the floor with toothbrushes. Not your own, because I'm kind. I'll buy you the toothbrushes. Good. Okay. Find the area under the graph. My floor will be so clean. Of f of x. My floor will still be clean, so I'm okay with it. Scrub brush. There's a little like sticky spot with the tape over there. I could get really good clean. It's right by you guys. You can check it out.
Where?
Yeah. From -1 to 1. So we're finding the integral from what to what? -1 to 1. So the area equals -1 to 1. E to the x, and what do I have to put? Dx, to say that it's a derivative, correct? E to the x dx. Now this is a calculator section. Boom, type e to the x and your y equals, right? And then you go second trace and you'd pick the integral symbol. Put -1 in, 1 in, enter. So try it out. Some of their outcomes are calculator outcomes. So sometimes they just ask that. If you're someone who's like e to the x, we can differentiate, right? That's an easy one. But sometimes they'll give you like e to the x sine x, and you can't differentiate it. And then you guys sit there and you are really mad at me because you're like, Lepp, you never taught us how to do these ones. I didn't have to. They're actually asking you to do a calculator outcome. They're actually asking you to just use your calculator. So you don't actually have to know how to do the antiderivative of it. So while you're getting mad at me, be like, I remember her talking about me getting mad at her. Why did she do that? And be like, oh, calculator. Yes. And then they'll be in the non-calculator section. You're like, I'm still mad at her. Okay. So on the test, on your test, what do you think? Where do you think I'm going to put these in? Written response. I wonder why. Shocking. Okay. So if I put one of these in your multiple choice, there's a good chance that it's one of them that you aren't supposed to do algebraically, and then you're supposed to do with your calculator. Correct? Okay? All right. So how do we do the definite integral? Well, what we do is we take the antiderivative of e to the x, and we put a plus c at the back to make sure that we can find that c if we needed to, which we did in antiderivatives. Here, when we do the fundamental theorem of calculus, we never find the c, because when you do f of b minus f of a, you're going to have a plus c, you're going to have a minus c, and they're going to cancel. So we don't actually even really need to deal with them. But when we show the antiderivative, we still show the plus c to prove that it exists. Okay? So we're going to go with the antiderivative of e to the x. Once again, party should be had, because the antiderivative of e to the x is e to the x. Now, if you are sitting plus c, sorry, and then you go -1 to 1 in the square bracket to show that it's still going. Now, if it was an indefinite integral, so there was no numbers on the integral, you would just go ex plus c and you'd be done. Box it and move on. Yeah? You have to include the c here, but then you can get rid of it later. Now, the other thing is, if you're stuck with an antiderivative, but you know it's like a basic one, so like the derivative of e to the 4x, I know is, rewrite it, ln of the base, ln e, which goes away, times 4, like the derivative of the exponent, right? I know how to go forwards really well. It's backwards that people are not always that great with. So had I given you e to the 4x, it's a little bit harder. I'm just going to do it over here. It's a little bit harder because it's not just e to the 4x, correct? But if you're stuck, always do the derivative of it and then figure out how you could just undo that. So if I actually did the derivative of this, so I went d over dx, so I'm saying I'm taking the derivative of it. I go d over dx is e to the x, I get e to the 4x. Then I get ln e, which does absolutely nothing. I'm just doing it to prove a point, because if it was for something other than e, you get ln 4, ln 2. And then you multiply by 4, we agree? So ultimately, in the end, I get what I gave you multiplied by the derivative of the exponent, correct? So if I gave you e to the 4x like this, dx, what would my antiderivative be? 1/4 e to the 4x, or you could write it as e to the 4x divided by 4. Same thing, right? You just have to undo what you did. So I know if I do the derivative, I'm going to multiply by 4. So if I do the antiderivative, I just rewrite it and divide by 4, right? So sometimes people get stuck on antiderivatives. You never should. You should always go, how do I do the derivative of it? Okay, I'm multiplying. I need to divide by that. Make sense? All right. Has nothing to do with this question because this question's easy. But we're going to go through it. So the fundamental theorem of calculus states that you just plug this in. So we're going to get e to the 1. You could go, I'm just going to show this, but you don't have to show the plus c's. So I'm going to show you once again why the c's don't have to be written. So we're going to add a c. So e to the 1 plus c. And then we go minus e to the negative 1 plus c. Correct? Now this minus sign is going to distribute through. We agree? So this is going to become a minus c and a minus e to the negative 1 and a plus sign. Well, the minus c and the plus c actually cancel. And they're going to every single time we do the fundamental theorem of calculus, correct? So do I have to show something that's just going to disappear? No. And they don't make you show it, but you do have to show the rest. So what are we going to be left with? We're going to be left with e to the 1. Do I have to write the 1? No. And then minus e to the negative 1, which is good. But how might they also write it? E minus 1 over e. Yeah. Now, some people want to say E has to be greater than, E is a number. You don't have to write a restriction. E can't be 0. It's 2.71, blah, blah, blah. I'll get people going, E has to be greater than 0. It is. It's 2.71. It could also be less than, like you just can't have it equal to 0, right? They say E can't equal 0. You're right, it can't. But why are you doing it? It's a number. It's like pi, correct? So please don't state like non-permissible values on E. It is a number. It's like having 1/2. Okay? So the questions we can work on for this one are problem 53. What section this is in is 5.3, just in case you forget. 5.3, problem 53, and AP practice problem 11. Okay, next example. So we have example 3. What they do in these, and this is more so you have to remember that calculus is used in a lot of like engineering and other factors. It's used in sciences, etc., in the maths. So when you do, people are like, I want to see the connection right now. Well, remember, you're learning everything. You're learning the basics of calculus in Calc 1. So you're learning how to find the derivatives. You're learning how to find basic integrals. You're learning how to find basic limits. And then in your next advanced lessons of calculus, you'll start using them in word problems and such, and stuff where you'd actually have to use them in engineering it and everything like that. But you have to learn your basic math before you can actually throw stuff at you, correct? So this is an example of what they can give you, and they do these in the written responses. So example 3 says the population of the United States is... Okay, the population of the United States is growing. Shouldn't have stopped there, I guess. At a rate of... Now, guys, at a rate of... The moment I put rate, what am I giving you? The derivative, correct? You guys know that. It's growing at a rate of P prime T, or P, yeah, prime T, equals 2.867, 1.009 to the T, million people per year. Where T, often they find base knowledge behind this, so it's probably not. Where T is the number of years since 2015. Now, if this is in a calculator section on the test, correct? If this is in a calculator section, you can't just type in some stuff. and give an answer. You can do that to get the answer, but you're going to have to show the integral stuff first. So you know, like back here, when they ask me what the area under the curve from 1 to -1 is, I can't just say it's e minus 1 over e and call it a day. What they're going to look for, if this is in the calculator section, what they would look for is they would look for you saying area equals, show the integral at the very least, and then give an answer, if it's in the calculator section. But you have to show how you figured out this. And if you're figuring it out by typing it into your calculator and going from -1 to 1 or 2 to 4, the way you show that is literally by showing the integral symbol 2 to 4 in the equation d of x, dx, right? And then you can put equals answer, approximately usually, because you're usually rounding it, okay? And that's what they're looking for. If you just have an answer, you're not going to get the full marks on that written response. They're looking for you to write the integral to show that you actually found the integral, and then you give an answer. Do you know what I mean? Do you have a question?
I was just going to say, like, why wouldn't this be like just a regular, like, 3-1 growth decay?
So what they do is they can throw it in a rate of change, and then, or they could do it in a basic one too. But this is just like, this is their way of giving you a basic word problem that they could use calculus on, right? Then we're going to get to ones where once you get to like second, third, and fourth year calculus, where you wouldn't be using just your basic growth function or decay function. Yeah, they'll have like different changes with like a base of k in them. And you'll see some of those. They do throw some of them in too. But yes, this is 100% one that could be used in a growth function that we did in 30-1. Wouldn't be set up the same though, because this is the rate of change, not the actual function. Okay, so I need a question to ask you. All right, so it says, I'm going to ask it this way. So we're going to say, they say find, I'll write it. I've just dealt with it, but it should say determine, as we know. Find 0 to 5 p prime of t dt. So what do I get? A whole bunch of people freaking out and saying, I can't do this. Well, you actually can. But we'll go through how to do it algebraically, and we'll go through how we can do it with our calculator, right? We'll go through both ways and what they would expect. So if we do the calculator first, what they're going to expect is they could actually say 0 to 5 pt dt and give an answer. You wouldn't even have to fill in p prime of t dt. You could just do this equals. Because, and only because, for AP, because the p of t is written above. The p prime of t is written above, so it already shows what it is, correct? If the p prime of t wasn't written above, you'd have to say, let p prime of t equal this, and then you could use p prime of t in the question and not write the question out. But because they state what p prime of t is, you actually don't have to fill it in here. So a lot of people do the extra step, and they'll go 0 to 5 p prime of t dt equals 0 to 5, 2.867, and I'm one of those people who it would kill me not to do this, so I'm not saying don't. But you don't have to, you could just write this and give an answer, and you still get full marks, because up top it shows what that formula is, okay? But you can fill it out. I think it would be hard for me to just be like, I'll just leave it. So I'd be like, but what if the one time they don't mark me fully? That's would be where my mark would be. I'll shred it out, okay? Doesn't really matter. But you're going to use your calculator and figure it out right now. So everyone go and type it into their calculator right now. And you're going to get it that way. And then I'm going to show you how we can actually do this. Not that way. So everyone, paying attention, everyone with any calculator can type this into our y equals and do it that way. Everyone with any type of calculator can do that. We agree? Anyone with like any of these, TI-83, TI-84, whatever. Anyone with the ones that had the log base button, so if you know if you're that person, if you had the log base button on your calculator, you have an extra function that you don't have to go to your y equals for. It's actually nicer. And this is why I promote parents to, if they're going to go buy a new one, to just spend the extra $20 and get the TI-84s instead of the TI-83s. However, if you have one that your sibling's great and doesn't lose stuff, and you somehow have had this passed down to you, then it's free. Use your TI-83, right? But if someone's purchasing one brand new, I'm always like, just spend the extra 20 bucks beginning of the year. Buy it. Because of this. Here's another nice one. So, is it that hard to type that into your y equals though and get something? No, it's not difficult. It's not. But there is an extra function that's nice to you. So what you can do, if you have the one with the log button, if you don't want to waste your time, it ain't going to be there. Maybe you can waste your time. Try it out. I don't think it's there, but go try. So you go to your main screen. Everyone's on their main screen. Then you press math, and you arrow up to where you would arrow up to log base, correct? But you keep arrowing up to FN, INT. Do you see above that it's N deriv? You can put your derivative in as well. I didn't tell you that earlier. You guys have it? Fun fact. I don't know how to type this in, though. Ours is nice. So when you do the function integral, it actually looks just like what's in front of your face. Like it'll pop up. And you just type it in exactly how it looks. So you guys are going to have the button, but I'm not sure exactly. I have to look at yours, Lucas. I'm not sure exactly how that. I think you have the button, but it's typed in here. Yeah, so you guys have, the TI-83s have the function pop up, but I have to look how you do it. You have to like type the function in, I think, and then comma, low base, comma, high base, or something like that.
Oh, I did the wrong one.
Honestly, for yours, it's easier to type each one.
Is it number 9?
What's this thing called? I can't believe that.
So sorry.
No, I have to look at the order. I don't remember what the order is. But it's, I think it's easier to put it one. And yeah, so it's like if you like to use that function instead. These ones just catches. So, reminding you that this, if you have the calculators where it pops up, you guys, you're not typing this in your y equals. It's just on your main screen, correct? So you have two options. You can either type your equation into your y equals, and then go low to bound to high bound, left, you know. Or if you have the newer calculators, you can go to your main screen and press math number 9, and then just type it in. Okay? Yours, there's something to do with like commas and stuff, I don't know, but honestly, it's just easier to put in your y equals. So I never go through and remember how to do it that way, because you can Google it. It'll tell you how to do it. But I just think the y equals, and you get it anyway. That's why I learned to.
I wouldn't even know how to do it.
Yeah, it's the only reason why I tell them on the new one, because it literally looks just like what's on the board. Like Wout can show you. It looks exactly like what's on the board. That's the reason why I showed them it. Okay, yeah.
I put my y equals like the 2.867.
Yeah. Yeah, then you get that. And then they'll say lower limit, you'll go to 0. Enter. Just take 0. Enter. And 5. Enter. So you still get it. All right. So you should get somewhere near 14.661. Yeah. So you guys would show, okay, approximately 14.661 would be your answer. We agree? Now people will say, we'll get to this spot and that's what we're talking about, well, when this is actually not in a calculator section, and then they get mad at me and they're like, we've never been taught this way. And I'm like, you have to remember this. So remember when you took a derivative of something, if it had a coefficient, the coefficient could just sit in front. We could do the derivative of the rest and add it to the coefficient. We agree? So same thing happens with integrals. We're going to do this one algebraically. So if I have, sitting in front of me, 0 to 5, so this isn't with my calculator anymore, and I have 2.867, 1.009 to the t, dt, I can actually take this coefficient and pull it out. So I could actually say 2.5, that's not a 5, 8, 6, 7, 0 to 5, 1.009 t dt. Now what you have to spot is, you know how to do this. You know how to do this. You know how to do when the base is a number and your exponent is a variable. You know how to find the derivative of that. An example of that would be like 4 to the x. If I gave you 4 to the x, how did we find the derivative, d over dx? How did we find the derivative of that? We rewrote it, ln the base, so ln 4, and then multiplied by 1. We agree? It's true. So if I take this one instead of being 4 to the x, say I say d over dx is 1.009 to the t. Well, how would I do the derivative of that? I would rewrite it, ln the base, so ln 1.009, and multiply by derivative of t, which is 1. And that 1 isn't doing anything, so I'm going to ignore that. So how do I undo this if this is a derivative? You're going to divide by ln 1.009. And just keep it and then divide by it, right? So let's try that out. So we're going to get 2.867. And then I'm going to go square bracket because I'm going to do just the antiderivative of that. So I'm going to get 1.009 to the t divided by ln 1.009, technically plus c. And then I have 0 to 5. Do you agree? So nothing you're not capable of. Everyone's capable of that. It's spotting that that is a numerical base to a variable exponent and that you know how to do the math with that. Right? 1.009t doesn't scream in most people's heads, numerical base, variable exponent. Rewrite, ln the base, times the exponent. You know what I mean? Like 4 to the x, I've drilled in your heads, but 1.009 to the t, not as much. So now we just do our normal fundamental counting principle. So we go 2.867. Now remember, if this is in a non-calculator section, people are like, oh, but Mrs. Lepp, I do not know the answer to ln of 1.009. Neither do I. Good call. So what are they going to expect you to have? Ln 1.00, like they're going to expect you not to turn it to a decimal. Because why? You're not in a calculator section. Understandable. Okay? So here we would have 1.009 to the 5 over ln 1.009 minus 1.009 to the 0. What's anything to the 0? 1. Will they expect you to turn that to a 1? Yes. They will expect you to turn that to a 1. They'll expect when you go e to the 0 to turn that to a 1. Right? Anything to exponent 0, they're expecting you to turn it to a 1. And then it would be over ln 1.009. So if this was a non-calculator section, I would have 2.867, 1.009 to the 5 over ln 1.009 minus 1 over ln 1.009. Box it, moving on. I can't do anything else. That is a whole bunch of numbers I cannot do. Yes, you could go 1.009 to the 5 minus 1 over ln 1.009. Absolutely. I didn't see that, but yeah, totally can. So we'll write that out. Now, we do have a calculator. Try and plug it in. You should get approximately the same answer, 14.661. So, you should get the same unless you typed it in wrong. But, that would be your error. So, call me over if you're still not getting it. But what they do on AP tests all the time, and I've seen it in calculus assignments as well with procs, is they want to like see if you actually know what the heck you're talking about or if you're just finding numbers. So here it says interpret from 0 to 5 p prime of t dt in the context of the problem. Now this is why this is why this one's better for the rate of change than just using the basic question, you'll see, because of the interpretation. So, what the heck does the p prime of t dt represent? Go back to the question. What does p prime of t dt represent? The growing, the United States is growing at a rate of that, right? Million people per year. T is the number of years since 2015, okay? So we know that p prime of t dt is the rate of change of the United States in growth. We agree? The population in millions. Yes? So what the heck does the 0 and 5 represent? The rate of growth from 2015 to 2020 in millions of population in the United States. What is it growing at a rate of? 14.661 million people per year. That's what it's growing at. That's not unrealistic. The United States is huge, just so you know. Like, we are large in area, not in humans. Okay? Google the population of the United States. Google the population of the United States.
It's like 350 million.
It's huge. I thought it was in the 400s.
Well, yeah.
Is it even more? I can't remember. I looked it up once. Can't remember what year it was. So, if this is actually real, I'm off by a few.
329.5 million, because that was 2020, I'm from 2020.
Okay, 300.
Now remember,
333 million.
this is a formula that they gave. Does it actually have to be accurate? Could it be not growing at 14.661? Sure. Are you going to write on the test, this seems wrong?
Yeah.
Your equation sucks.
Your
Try again.
questions.
I will
You're not. You're not going to do that. They're marking you.
I can't
We
wait for critique the questions.
don't.
I like writing essays.
Stop it. So, what we're going to write is the projected change in population. Now remember, this is just a projected change. So they can do stuff like this if they're trying to figure out projections on like highways and stuff like that, or like areas of growth in a city in the United States, trying to figure out stuff like that. Have you ever seen how well their highways run compared to ours? Like, you drive through United States city, you just look up, and yes, you might be bogged, but if they had our type of roads, you would never, like, you'd be sitting in traffic for like 7 years. Like, you would not be moving. If you ever go to the United States, there's like overpass, it's like 7 overpasses deep. You go drive through Calgary, you're like, they put in 1 overpass. We don't have a light. Like, my husband's always like driving through Calgary, he's like, could be an overpass, could be an overpass, should be an overpass, as we're driving down the cloud. If this was the United States, there would be an overpass. There'd be probably 7, but yeah. Obviously, our cities aren't as big as theirs, but you know what I mean. Okay, so they use projections like this to help themselves out. So this here is the projected change in population and we have to make sure we say in millions because that's what they told us, right? In millions is 4.661. I should say, yeah, it's not 4 at all. Is growing, you have to put that because it's positive, right? Is growing at a rate of 14.661 from 2015, yeah, million people. From 2015 to 2020. Sorry? Per year? Yes, we need that. Is that what you said? Yeah, we do. That's a schwoops on my behalf. If not, it could be assumed that it's the whole time of 2000. Yeah, you need per year. Very good. All right. Now C says, if the population of the United States was 320 million people in 2015. This gets asked a lot. All like this whole type of question is like written response extraordinaire on the AP test. Like part A, part B, part C. Yep.
Because you put in millions in brackets already.
You could have gotten away without putting millions. Yep. But once again, I don't chance losing a mark somewhere, so I will continue to write millions after. But you wouldn't have.
Okay, but aren't you saying now that you have 14.6 million people from...
No. Yeah. But you wouldn't. But I see what you're saying. Okay, if the population of the United States was 320 million people in 2015, the reason why they'll say millions people so that when they fill in the formula, they don't have to go 320,000,000, right? So we went over this in like, I did it in grade 11. I talked about skateboards back in grade 11. They were making skateboards and they were trying to optimize the skateboard costs and revenue. And so what they could do is they could say, I think it's actually 30-2 that it's in. You'd say like 10 represents skateboards in the thousands. So then that would be 10,000 skateboards. You wouldn't have to put in 10000. And the reason why is they do regression, so you have to type it into a chart, into your calculator, into like list 1, list 2. So then you're writing 10 instead of 10, 000, 20, 000, right? So they'll say in thousands, and then you can just write 10 or 20. So it's more so for filling it into the formula, or it would deduct you, but I see what you're saying. Okay, there are 320 people in 2015. What is the projected population? In 2020. Don't let it overwhelm you. Let's just use our brain cells. So, if we were just doing this mathematically, let's pretend there's no calculus involved, we're just doing this mathematically. What numbers would we add to get the final population in 2020? If we were just doing this mathematically, we're not in calculus, we're just doing math.
120 plus the rate of change per year times 5.
Right. So we would take the population in 2020 plus the changing rate per year from 2015 to 20, like 20, right? Okay. So they want to know this. So the way we write it, because we are in calculus, is we're going to go. It's not per year. Why do we put? That's why we don't put per year. It's the rate. I followed Seamus, but it's not per year. What does it say back here? It says.
That's it, Seamus.
Seamus didn't say it. It was Shmamus. Another human popped in. It was Wout. It was Wout.
I'll take the play.
Totally Wout. Because here in the actual question it says P of T, millions people per year, where T is the number of years since 2015. But then it gives you it's the changing rate, but then you get the total. Because you're getting the area under the curve from 0 to 5. We have to think about the fact that we're getting the total. We're getting the area under it. We're not getting it. If we wanted to do it per year, we could go 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and add them up. That would be stupid, but we could go and do that. Yeah, because you have to think about it. Whenever we're using the integral, we're doing the area under a curve, so we're getting the total population. Yeah, take per year off. It was correct till I added the per year.
So
Then it went down here.
the change.
Yes.
So,
It's just the change in people from
2015 to 2020, that many
Right.
people were-
correct. Sorry?
Was it like growth?
The growth. Yes. Yeah.
Why are we growing?
So, how would we write this out? We would go
No, we're not. We're talking about how to say people anymore.
P of 5, the population in 5 years, or the population in 2020, but we wouldn't write P of 2020. We'd write P of 5, right? Equals P of 0 plus 0 to 5 P prime of T dt. And at this point, you can put in two numbers, get an answer, because you showed the work above, correct? So do I have to show again 0 to 5 p prime of t dt, do the algebra, get the answer again? Do I have to do all that work again when it's above? No. If it's part of your question, they're going to look at you. They have to get through it to get to that part. You don't have to redo it. So we know that in 0, it's 320. Plus 0 to 5 was 14.661. And so we're going to get 334.661 million people. So it's easier to do these questions if you keep remembering that every time you take the integral of something, you're finding the area under the curve of that value. You're going from 0 to 5, all the total area under that curve. So you found the total number of people that changed, which makes more sense in 5 years to grow by 14.6 than every year 14.661. Yeah.
And you don't need to write like approximately for either.
You can. Honestly, they're not the they're more stickly on the fact that you round to 3 decimal places. Unless they request a different decimal place, which they've been doing recently randomly. I don't know. Seen on the last few where like random ones like it's in your tens or something like that. But it's never significant digits. Okay, so it's problem 63 is what you can do. We're still in section 5.3. Problem 63. And you will see questions just like this when we start doing the practice tests, because these pop up all the time as like one of the questions. And AP practice problem 13. Okay. We have one left. So example 4. The graph of f of t equals sine t from 0 to 2 pi is. Now we would sketch it ourselves, and we can sketch a sine t graph because it's just, you're just sketching the graph from 0 to 2 pi off the unit circle. So you're literally sketching the x's being the degrees or the radians, and the y's being the y's, because sine is y, cos is x, remember? So if we go to sketch it, we have 1, we have -1, we have sine of 0 is what? 0. Now we can pick a whole bunch more, but I'm just going to go pi over 2. We'll have to curve more properly, but that's okay. Pi, 3 pi over 2, and 2 pi. Now remember, we have a whole bunch of other ones in the along the way on the unit circle that we could sketch as well. But I'm just doing a really quick sketch. So at pi over 2, what's it at? Sine is what at pi over 2? What is y at pi over 2? 0. Sorry, 1. I'm saying 0 and plotting the right dot. 1. And then at pi, it goes back to, what's my y at pi? 0. And then what's my y when I go to the very bottom of the circle? -1, which is 3 pi over 2. And then at 2 pi? And then it's doing some sort of like, pretend that that's a really well drawn graph. It's not too bad. It's not that great, but it's okay. So we have a little sketch, right? So A will say this. A will say, find the accumulation function. It actually hurts my heart every time I write find, but I'm adapting. Function f, capital F, associated with f over the interval to 2 pi. If it asks for accumulated function, it's literally asking you to find the area under the curve from there to there. What do you suspect the answer is going to be?
0.
Yes. It's going to be 0. Why?
When you drop below.
This is positive, this is negative, it's symmetrical, we know that. We know that the area above is equal to the area below. We're going to get an answer of 0. We know that because we know what a sign graph looks like. Right? Okay. So, now if it wasn't 0 to 2 pi, if it was 0 to pi, totally different story. It would just be what's above, right? Okay. So, we are going to find f of x equals 0 to x. If they're giving us this as the question, sorry. 0 to x sine t dt. This is what they gave us. We just happen to know it's 0 to what? 0 to 2 pi. How do I find the answer to that? You just do the antiderivative every time. If you're like, I wonder what I should do, antiderivative. Don't wonder, just do. If it's a multiple choice question in a calculator section, use your calculator. People are like, but I must do the math. You can, if you have time. So if it's a calculator section, remember your AP test is timed, and I'll show you exactly what's in each and how much time you have and how much approximate time you have on each one. We're just going to deal with that after the break because I don't want to make anyone have to worry about it. But 0 to 2 pi sine dt dt. If this is in a calculator section, I'm going to type it into my calculator in radian mode and get an answer. And then if I still have time left over, I'm going to go back and do it algebraically because I know I can do this one algebraically. But they put times on things assuming you're going to use it correctly. So you're going to use this as a calculator. That's how they'll assess this one. Okay? So 0 to 2 pi sine dt sine t dt. So we're going to get the antiderivative of sine is no, it's not. It's negative cos. Because the derivative of cos is negative sine, correct? So sine, if I work back, is not cos. Sine, if I work back, is negative cos. So I get negative cos at t, I want to put x, plus c, 0 to 2 pi. So I'm going to go negative. Now, that negative 1, I could technically completely put outside. Could I not? Because it's just a constant. So you can do that. Or you can carry it along. Don't matter. I'm going to carry it along. You could leave it out. If you leave it out, you can distribute it in. It doesn't matter. So, cos 2 pi minus negative cos of pi. Add 0. I think that's not at all the thing. Okay, what's cos at 2 pi? 1. Because it's x, correct? What's cos at 0? 1. So I'm going to go minus negative 1, or minus, yes, negative 1. I questioned myself for a second there, but there's a negative. And so it's 0. Now, how else could we have done it? I said we could have, there's a constant. So what could I do? I could go negative 1 cos, just to show you, because I don't care which way you go as long as you get it correct. So we go negative 1, and then we go cos of 2 pi minus cos of 0. Cos of 2 pi minus cos of 0 is 1 minus 1. So it's negative 1 times 0, which is 0. Ultimately the same answer. So do I care which way you go? I care that you use the one that you won't get wrong. So whichever route you go. Now, if you have more than one term, so say you had like negative cos x plus sine x, could I take the negative out on the cos? No, I would have to go, it's like they're attached. It's if it's like a monomial and you have a coefficient, you can put it up front. You know what I mean? If you split up integrals, but that gets all complicated too. Okay, so this one has just AP practice problem. Problem 8. And that's on 5.3.